This is Mr. Ward, and this is the key for Geometry Do Now 26.3. And in this, I'm going to be introducing a couple of theorems in the Do Now and the Exit Ticket for us to prove that are from Chapter 7, Section 2. The first theorem is called the no-choice theorem, and this will set up the next theorem, which is called angle-angle-side, which is another tool we can use for proving triangles are congruent. So the no-choice theorem simply says that if two corresponding angles, say A and D, are congruent, and B, two sets of corresponding angles, so A and D are congruent and B and E are congruent, then the third set of angles will have no choice but being congruent. So if we have angle-angle, we can prove angle-angle-angle. So that is basically what this does. This shows that a third set of angles must be congruent if the other two sets of angles are congruent for a couple of triangles. However, theorems need to be proven. We can't prove them by just referring back to the theorem we're proving. We can't say, oh, well, this is true because of the no-choice theorem. You can't prove the no-choice theorem that way. So please use the diagram instead and the givens to prove that angle C is congruent to angle F. This sets up a situation that allows us to do that proof. So we know angle A is congruent to angle D. We know angle B is congruent to angle E. So we have given angle A is congruent to angle D, and angle B is congruent to angle E. Cool, we've been given that. Okay, we also know that angle A plus angle B plus angle C, the measures of those equals 180. Now, to be really precise, I want to put an M in front of each of those because that is a measure, not just the angle. Okay, so the measure of the angles has to be equal to 180. We have that from one of the theorems we got yesterday. And by the same, we can also say that we can add on the other side of that equal sign that angle D, the measure of angle D, plus the measure of angle E, plus the measure of angle F also equals 180. So I put both of those on either side of 180. Cool. So now that means by transitive property, that's the triangles have 180 degrees. Okay, and then we can do this by transitive property. I can say that. And then since measure of angle A and B are the same as measure of angle D and E, I can subtract measures of angle M and B from this side, and I can subtract the measures of angles D and E. And this is basically by algebra and substitution, essentially. Okay, so those are things we're using here. It's basically by algebra. So once we've done all that, we're left with the measure of angle C is congruent to the measure of angle F. And so our conclusion is that since the measures are the same, angle C is congruent. Oops, actually, that should say equal since they're measures. Okay, but since the measures are congruent, the measures are equal, the angles are congruent. So angle C is congruent to angle F by algebra. Okay, why can't we use a theorem we were proving to prove that theorem? Well, what do you think? Your answers are going to vary, but essentially the deal is you cannot say hats are real simply by asserting because hats are real. That is what we call a circular argument. The fancy word for that is, so it is an argument that doesn't actually go anywhere. It doesn't actually provide new evidence. There's a fancy word, it's called a tautology. It would be a circular argument that provides no actual evidence or proof. Formal name for this is a tautology. That is a word. Okay, so if I wanted to prove that trout are fish, I would say trout are fish because I know that trout are fish. Okay, that doesn't tell me anything. Hats are real because hats are real. Giraffes are secret government robot spies because giraffes are secret robot spies. This is not a logical deduction. It does not draw from any kind of evidence or proof. So we do need evidence. We need to be able to make a basis for the proof. I hope that helps.